Hey guys, this is Integrated Science Unit 2. We are still on Skill 1, Pressure, and we are doing Part 5 of that right now. So we're going to finish up the last bits of pressure we need to talk about. So far we've seen this hydraulic press situation where you have an input force and an output force, and generally the output force is doing something. So we got this formula before, force 1 divided by area 1, so that would be the force applied, and then the area where it's applied at, equals force 2 divided by area 2. So this would be the output force, the force coming up, and that's generally drawn on the right-hand side, and then the area 2. Now that doesn't mean that all hydraulic presses happen to the right side. It's just when we do our sketches in physics class, we generally do it always input on the left and output on the right, just to keep things simple. This doesn't happen in real life. Real life, everything is all sorts of sizes, but just to keep things clear for you. All right, but we need to talk about something else today, and that's the height. Okay, you noticed something funky happened with the height during the syringe activity, and here's the formula you need to know. Force 1 times height 1, so 1 is always over there on the left-hand side. So the input force times the change of height is equal to the output force over there on the right times the height. And when I talk about height, I mean changes in height. You guys did this activity with syringes in class where you pressed on the input and saw the output. And if you noticed, when you press down on the input goes a lot further than how far the rate of change of the output. So if we bring it back to where we started, ooh, it is so much harder to press on the larger side. So I'm doing a really rough estimation, but just about the height of my thumb above where this plastic piece is. If I go the whole thumb down on the small tube, notice it's only a little bit above my thumb now. So this large one only went a little bit compared to the smaller syringe went really far. And also, as I said, the smaller syringe, it took less force, right? This is really hard to press because this is a large syringe. I have to put a lot of pressure because I'm putting pressure on every single piece of liquid underneath, versus this only has a small amount of liquid in the area underneath. So as I press, it doesn't require as much force because I don't have to make as much pressure. So let's look at a hydraulic pump here. So remember, this is our input pump here and our output pump here. So over on the left for our input pump, initially our piston was here and it dropped because of this force 1 to where it is now. All of the fluid that was moved in that area, we're going to call that volume 1. So that's the first volume. Volume is how much of something, like how much space it takes up. All of this fluid came down the pump to the connecting area and then went across and went up into the output pump. So see how this height 2? Here is volume 2. That's how much more fluid is on that right-hand side. So volume 1 is the change of fluid on the left side. Volume 2 is the change of fluid on the right side. Now, whatever fluid was displaced by piston 1, so whatever fluid was pushed out of this first piston, by this first piston, had to be the same volume of fluid displaced by piston 2. What do I mean by that? Volume 2 is the exact same amount of fluid, whatever that is, whether that's gas or liquid, as volume 2. Volume 1 and volume 2 are equal. Now, if you think about what volume is just area times height. So if you have, you figure out the bottom area and then how tall it is how many times that bottom area happens, that's the volume. So if this volume is area times height, then area 1, that's that area of the actual piston, times the height, the change of how low it dropped, is equal to area 2, which is again the size of that piston, and in height 2, how much that output piston was raised. So this is a good formula to have. And let's work out a problem. A 6,000 Newton force acts on an input piston of 0.13 meters squared. Remember, meters squared already tells you that you're talking about the area of something, causing it to drop 3.2 meters. If the output piston is 1.8 meters squared, how high will it be pushed into the air? The first thing I'm going to do is draw a picture. So I suggest you draw this. So here is my input piston, my output piston. This is a very, very, very basic drawing. When this 6,000 Newton force pushes on my input piston, it's pushing all that fluid, and that fluid is going to be pushed over to the other side and go up the output side. We know that area 1 is 0.13 meters squared. It's written right here. And what's going to happen is when that force happens, that input force, this piston is going to push down to the point where it drops 3.2 meters. So now it's here. So you lost all that volume right there, and all that volume was pushed over here and added to our output side. So we know that our output side has an area of 1.8 meters squared, and some force came up when all that fluid came there, and so it rose, and it rose by height 2. We don't know what height 2 is. We don't know force 2 or height 2. But what we care about is how high will it be pushed into the air. So the formula we want is the one we learned today. Area 1 times height 1 equals area 2 times height 2, because that's the one with height in it. If we're trying to solve for height, our top formula, our formula from last lesson, won't work. I just put them up there because when you guys are solving problems on your own, you're going to wonder which formula am I going to use. Make sure you use the one that matches what you're trying to solve. So we use this formula. Area 1 is 0.13 times height 1, 3.2. So that equals area 2, which if you look over here, area 2 is 1.8 times height 2. And we don't know height 2, so you leave that as h. You want height 2 by itself, so since you're multiplying it by 1.8, you have to divide by 1.8. Those will cancel. Whatever you did on the right-hand side, you have to also do on the left, so divide by 1.8. This whole thing you should put into your calculator in one step. Do 0.13 times 3.2 divided by 1.8. And then you'll get 0.23 meters, and that's your height. So 0.23 meters. I put meters on it at the end because I'm talking about height, so that should be meters. All right, the next thing we can talk about is mechanical advantage. So this is a really important concept for mankind. We use it all the time to make our lives easier. Mechanical advantage occurs when a tool allows a greater force to be produced than the force applied. So when you press on your brakes, you're not actually like putting forth the force that it requires to stop your car. That would be impossible for your foot to press that hard in that amount of space. So we use a mechanical advantage. We use mechanics to make things easier, and there's a formula for it. Mechanical advantage is the output force divided by the input force. There's no unit for mechanical advantage. Something could have a mechanical advantage of 3, meaning the output force is 3 times bigger than the input force. If something has a mechanical advantage of 7, then whatever force you put in, a 7 times as big force is going to be used in the end or observed in the end. If a machine is to provide a mechanical advantage, the MA or the mechanical advantage number must be greater than 1. So if you're putting a force into a machine and it's giving out less of a force, then it doesn't have a mechanical advantage. So a mechanical disadvantage maybe, but definitely not a mechanical advantage. All right, so in the previous problem, what was the mechanical advantage? So I brought forth all of these formulas that we've used before, and let's bring, or that we've had so far. So we want to find the mechanical advantage. That's this thing. We need the output force divided by the input force. And if you notice, I don't have the output force, which means I need another step. I need to go back and use another equation to solve my output force. So if I look at these two, which one has force? It's going to be the top one. So the top one, the top formula is force 1 divided by area 1. So let's do that. 6,000 is the input force, divided by the input area is 0.13, equals force 2, that's what we want to solve for because that's our output force. Force 2 and output force are the same thing. So equals force 2 divided by area 2. So this is coming from this top equation. I need to solve the top equation to find my output force, so then I can plug it into my mechanical advantage formula. If you have two fractions set equal, always cross multiply. So that's going to leave me 1.8 times 6,000 equals force 2 times 0.13. I know my equal sign is in a little weird place. You'll see why in 2 seconds. So I am going to get force 2 by itself. To do that, since I'm currently multiplying force 2 by 0.13, I have to divide by 0.13. So there you go. Those two will cancel. And whatever you did on the right, you have to do on the left. Since this is all multiplication and division, I can do it all in one step in my calculator. 1.8 times 6,000 divided by 1.3. I'm sorry, divided by 0.13. Okay, so you're going to get an output force of 83,077 newtons. We know our input force. It was given to us way back in that first problem. It was 6,000 newtons. And we're getting an output force of 83,077 newtons. So this is obviously giving out more force than what you put into it. So it does have a mechanical advantage, as in the MA is going to be greater than 1. Let's use our formula. So MA is output force divided by input force. So output force is the same thing as force 2, 83,077 divided by 6,000. And that gives us 13.85. So the mechanical advantage of this hydraulic press is 13.85. Now I want you to take a minute and compare some other things and see if you get anything close to 13.85 with any other numbers. See if you notice any pattern. All right, so you might have noticed that, yes, force 2 divided by force 1 is the mechanical advantage. But in the last problem, if you took area 2 and divided it by area 1, you would also get the same mechanical advantage, that 13.9. And if you took height 1 divided by height 2, that gives you your mechanical advantage too. So you can also solve problems using area and height to figure out the mechanical advantage of a situation. All right, good luck with the section, and I will see you in the next set of notes.